Question 1. Which of the following shapes has a perimeter of 12 centimeters? Now, perimeter is the distance around the outside of the shape. So if you take, for example, option B, 4 plus 3 is 7, 7 plus 2 is 9, can't be B. You're probably saying, no, it's A. Of course it's A. A rectangle has opposite sides equal. So if that's 2 centimeters there, so this is the height of the rectangle. This one here is 2 centimeters as well. Opposite sides are equal and parallel, of course, in a rectangle. 4 centimeters for the length down here. This one's also 4. 2 plus 4 is 6. 6 plus 2 is 8. 8 plus 4 is 12 centimeters. So the answer is A. Question 2. Sugar is sold in 4 different size packets. Which is the best buy? So the way to answer this question would be to maybe look at a common mass. So for example, the cost per kilogram would be something to compare against, and then compare the cost per kilogram for each of the options. So for 100 grams, it's 40 cents. Okay, so if we multiply that by 10, okay, because there's 10 lots of 100 grams in a kilogram, we end up with 1 kilograms is equal to $4 for this option. Okay, now clearly we have 1 kilograms for $3.50, so we can't be option A. Okay, what about option B, 500 grams for $1.65? So if we multiply that by 2, because there's 2 lots of 500 grams in a kilogram, 2 times $1.65 is $3.30. So 1 kilogram is equal to $3.30. So clearly it's cheaper than option C. So far it's between option B and option D. Now, option D, if we halve that one there, okay, two kilograms becomes 1 kilogram. $6.90 is $3.45. So the cheapest option is clearly B. Question 3. Chris opens a bank account and deposits $1,000 into it. Interest is paid at 3.5% per annum, compounding annually. Assuming no further deposits or withdrawals are made, what will be the balance in the account at the end of 2 years? Okay, so this is just a standard or a regular compound interest, present value to future value scenario. So future value is equal to the present value multiplied by 1 plus the interest rate as a percentage per period to the power of n, which is the number of compounding periods. So the present value is $1,000. 1 plus the interest rate, which is 3.5% per annum, which means per year. So I'm just going to write it as a percentage. Compounding annually, so that's important to know. Okay, so each compounding period is 1 year, and the number of compounding periods is 2 because it's at the end of 2 years. So it's going to be to the power of 2. Okay, so entering in this expression to the calculator, 1 plus 3.5% to the power of 2, and we get $1,071.23. Okay, so it's going to be option B. Question 4. Which compass bearing is the same as a true bearing of 110 degrees? What we'll do first is we'll draw a quick compass rose. There's north. Okay, that's 0, 0, 0 degrees using 3-figure bearings. 110 degrees, okay, that's just south of east, isn't it? So that's 0, 9, 0. There's south, which is 180 degrees. 110 would be somewhere there, okay? So there's 110 degrees. So that's going to be south 70 degrees to the east, because from south, measuring back towards east, we need to go back 70 degrees. Okay, so this bearing here is south 70 degrees to the east. And so the answer is C. Question 5. The Coordinated Universal Time, UTC, of Auckland is plus 12 hours and the UTC of Chicago is minus 5 hours. When the time in Chicago is 2 p.m. on Thursday, what is the time in Auckland? Now clearly Auckland is plus 12 hours ahead of UTC, which in the old terminology is Greenwich Mean Time. So Auckland is well ahead of Chicago. In fact, if you were to draw a quick number line, okay, there's 0, which is our UTC. Auckland is 12 hours ahead of UTC. Chicago is negative 5 hours behind UTC. The difference between negative 5 and positive 12 is 17 hours. That means that Auckland is 17 hours in front of Chicago. So if it's 2 p.m. on Thursday in Chicago, adding another 17 hours to that will give you the time in Auckland will actually be on Friday. So in actual fact, the only option that has a Friday in it is option D. So it's going to be 7 a.m. on Friday. Question 6. Mary is 18 years old and has just purchased comprehensive motor vehicle insurance. The following excesses apply to claims for at-fault motor vehicle accidents. Basic excess of $850 for each claim. So that means regardless of age or regardless of who the person is, there's $850 paid up if you're at fault. Second point, an additional age excess of $1,600 for drivers under 25 years of age. Mary is 18 years of age. So we can see immediately that this is going to apply and this point here is going to apply. Now the third point, an additional age excess of $400 for drivers 25 years of age or over with no more than 2 years driving experience. Now again, we've seen that Mary is 18 years of age, so this point here does not apply. How much would Mary be required to pay as excess if she made a claim as the driver at fault in a car accident? So we can see already that in our analysis, and if Mary was at fault, it'll be $850 plus an additional $1,600. So it'll be option C. Question 7. Julia earns $28 per hour. Her hourly pay rate increases by 2%. How much will she earn for a 4-hour shift with this increase? So let's see how much she earns currently. $28 per hour. She works for 4 hours, but her pay is going to increase by 2%. And the way we implement an increase in mathematics is to multiply by 102%. Okay. So $28 an hour times 4 hours times 102%. We get $114.24. Option D. Question 8. A person's weight is measured as 79.3 kilograms. What is the absolute error of this measurement? When you talk about absolute error, it's to do with the smallest unit of measure or the smallest unit that this measurement implies. And the smallest unit is 0.1. Look at the steps. 79.3 kilograms. The next step up is 79.4 kilograms and so on. So the smallest unit of measure, okay, is equal to 0.1 kilograms, which is equal to 100 grams. And the absolute error is half of this. Okay, so that's going to equal 50 grams. Answer is B. Question 9. What is the interest earned in dollars if $800 is invested for X months at a simple interest rate of 3% per annum? Simple interest means we're going to use the formula I equals P times R times N. Now, the P, the principal, is $800. The interest rate is 3%. Okay. Now, the time, the N, is X months. But the interest rate is per annum per year, which means that we have to divide the X by 12. So I'm going to multiply this by 1 on 12 times X months. So this converts X months into years, or converts it into the time unit of years. Now, multiplying all this together, okay, so, 800 multiplied by 3%, multiplied by 1 on 12 times X, and we get 2. So the answer is 2X. Option A. Question 10. A school collected data related to the reasons given by students for arriving late. The Pareto chart shows the data collected. The way we're going to answer this question is we're going to use the cumulative frequency polygon. We're going to look at train or bus delay. Now, at this point here, this is 92%. But because it's cumulative, this includes all the other reasons in front of it as well. So this includes sleeping in, family, and appointment. So we can't include these 3 columns. This point here is 86%. And this 86% refers to appointment, family, and sleeping in combined. So 92% minus 86% will give you the percentage contributed by just train or bus delay alone, and that'll be 6%, which is option A. Now, the other way you could do this is to add up all the columns individually, get a total, and then divide train or bus delay by the sum of all these columns, but that'll take you a lot longer. It's much quicker to use the cumulative frequency polygon and just understand that it is cumulative, which means that if you take a point and subtract the point before it, that'll give you the percentage contributed for that particular reason. Question 11. Which of the following correctly expresses y as the subject of the formula 3x minus 4y minus 1 equals 0? So what we're going to do, we're going to leave the negative 4y alone. Okay. We're going to move the 3x over, so it becomes negative 3x, and we're going to move the negative 1 over to the other side, and it becomes positive 1. Next thing we're going to do is we're going to divide by negative 1. So 4y is equal to 3x minus 1. Okay, so by dividing by negative 1, or multiplying by negative 1, it switches the signs of all the terms on the other side. And then lastly, we're going to divide everything by 4. So 3x minus 1 over 4. And that'll be option C. Question 12. An owl is 7 meters above ground level in a tree. The owl sees a mouse on the ground at an angle of depression of 32 degrees. How far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? First thing we do, let's draw a wireframe sketch. There's our tree. There's the ground. Here's the straight line distance. There's the mouse. Okay. There's the owl. 90-degree angle. Now we'll draw in our angle of depression, which is drawn reference to a horizontal. Now the angle of depression and the angle of elevation are in fact identical, and from the owl, from the top of the tree to the ground, is 7 meters, and we want to find the straight line distance. According to Sokotoa, this is going to be sine because it's opposite over hypotenuse. So sine 32 degrees is equal to 7 over x. X is equal to, you can just move the 7 on top of the sine 32, and then just enter that into your calculator. So I'll just do that now. 7 over sine 32 degrees, and we get 13.2, which is option D. Question 13. The graphs show the future values over time of P dollars invested at 3 different rates of compound interest. Which of the following correctly identifies each graph? Let's have a look at the graphs carefully. curve W and curve X are fairly close to each other. We would expect that the compound interest rate for W and X to be fairly close. Y should be quite a lot lower. Look at option A and option B. Option A shows W with 5% interest versus X at 10% interest and Y at 10% interest. W should be the highest, so it's not option A. Option B also shows W at 5% interest and Y at 10% interest, and that doesn't make sense, so can't be option B. W should be the higher rate of interest. Option C and option D shows the interest rates identical in fact. In fact, they almost look the same, like the same option. The only difference is that W in option C, W is being compounded quarterly, X is being compounded annually. The more often something is compounded, given the same principal and the same interest rate per annum, the more often the compounding, the higher the future value. This is compounded quarterly. This X is compounded annually. Whereby in option D, W is compounded annually, X is compounded quarterly, so this would imply that X should be higher than W, so it can't be D. The answer is option C. Question 14. Last Saturday, Luke had 165 followers on social media. Reese had 537 followers. On average, Luke gains another 3 followers per day and Reese loses 2 followers per day. If X represents the number of days since last Saturday and Y represents the number of followers, which pair of equations model this situation? Now, the numbers 165 and 537 represent a y-intercept. So I would expect the y-intercept for Luke should be 165. So clearly option B could be 1, but not option A. Nor option D for that matter. The y-intercept here is 3. So we've got a choice between B and C. Now, let's have a look at the number of followers per day, or the gain or loss, the number of followers. Luke gains 3 followers per day. So I would expect a gradient of 3 for Luke. Reese loses 2 followers per day. I would expect a gradient of -2 for Reese. Now X is the number of days that passes. So for every day that passes, Luke is gaining 3 followers per day. Reese is losing 2 followers per day. So I expect to have an equation that models Luke's gains to have a 3x in it. Here it is. Also expect an equation that models Reese's losses to be -2x. And here it is. So the answer is option B. Question 15. The scores on an examination are normally distributed with a mean of 70 and a standard deviation of 6. Michael received a score on the examination between the lower quartile and the upper quartile of the scores. Which shaded region most accurately represents where Michael's score lies? Now, first thing to note is the standard deviation of 6 and the mean of 70. Plus or minus 1 standard deviation is 68% of the scores. Michael received a score, however, between the lower quartile and the upper quartile of scores. So this is the middle, or this represents the middle 50% of scores. So, for example, let's have a look at option A. Between 64 and 76 is 68% of the scores. But Michael achieved the mark in the middle 50%, which should be inside 64. So it should be greater than 64, but less than 76. So it looks like option A is in fact the correct answer. Just while we have some time, let's have a look at option B. Option B is incorrect because from 64 to 76, this is 68. Again, 68% of the scores lie between here and here. Option C. This is beyond plus or minus 1 standard deviation. In fact, this is greater than 68% of the scores because we've actually gone beyond plus or minus 1 standard deviation. All right? If you were to draw a box and whisker plot, going from Q1 to Q3, lower quartile to upper quartile, has 50% of the scores. Again, should be inside 64 and 76. And clearly D is totally incorrect. That's just above a mean of 70. So that makes no sense at all. Question 16. A bowl is in the shape of a hemisphere with a diameter of 16 centimeters. Now, first thing is I'm going to write the radius as 8 centimeters because the radius is half the diameter. What is the volume of the bowl correct to the nearest cubic centimeter? Now, the reason why I write the radius is because for most calculations, the radius is in fact more important. Now, a hemisphere is half a sphere. So, volume of hemisphere is equal to 4 over 3 times pi r cubed, but we need to divide it by 2 because it's a half sphere. That's what a hemisphere is. Let's substitute in the radius. Okay, it's important to show all you're working out. Pi times the radius cubed, so that's going to be 8 cubed, and we're going to divide that by 2. So 4 over 3 multiplied by pi multiplied by 8 cubed divided by 2, and we get 1072. And its volume, so it's cubic centimeters. Question 17. The diagram shows a triangle with sides of length x centimeters, 11 centimeters, and 13 centimeters, and an angle of 80 degrees. Here's the diagram. Use the cosine rule to calculate the value of x correct to two significant figures. So to get full marks, we need to use the cosine rule, show the working out, of course, and make sure that we round the answer correctly. So, cosine rule. X squared is equal to 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80 degrees. So, working out that line there, so that's 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80. Okay, and we get 240.3366212. But of course we want the square root of that. Okay, it doesn't seem realistic that we have a side of the triangle that's 11 centimeters, a side that's 13, and another side that's 240. So we need to take the square root. Okay, so x is equal to the square root. Notice that I haven't rounded. We do all the rounding at the very end. Okay, so just to save a bit of time, square root, answer key equals 15.5027. So what I'm going to do is I'm just going to write down a few extra decimal places, or a few extra significant figures in this case. Okay, but we want two significant figures. Okay, so that means first significant figure, second significant figure. We don't go any further. However, the third significant figure will round the second significant figure upwards. Okay, so that's going to equal 16 centimeters correct to two significant figures. Question 18. Andrew, Brandon and Cosmo are the first three batters in the school cricket team. In a recent match, Andrew scored 30 runs, Brandon scored 25 runs, and Cosmo scored 40 runs. Part A. What is the ratio of Andrew's to Brandon's to Cosmo's runs scored in simplest form? Okay, so we can make sure we underline that. Now, let's have a look at their runs. Andrew scored 30. runs. Brandon scored 25. So make sure we maintain the correct order. Cosmo, last, scored 40 runs. Now, we can see that all of these terms are divisible by 5 because they end in either a 0 or a 5. So what we're going to do is we're going to divide all terms by 5. So 30 divided by 5 is 6. 25 divided by 5 is 5. And 40 divided by 5 is 8. So there's the simplified ratio. Now part B. In this match, the ratio of the total number of runs scored by Andrew, Brandon and Cosmo to the total number of runs scored by the whole team is 19 to 36. So this 19 here is the term that refers to the runs scored by Andrew, Brandon and Cosmo. So for every 19 runs basically scored by these three players, the whole team has scored 36 runs. So the first thing we need is the total number of runs scored by Andrew, Brandon and Cosmo. So 30 plus 25 plus 40 is equal to 95 runs. So what we want to do is you want to find an equivalent ratio. So 19 to 36 is equivalent to 95. So this is 95 runs, okay, scored by these three players, to X, where X is the total number of runs scored by the whole team. So the way we're going to work this out is by this calculation. 95 divided by 19. Then we're going to multiply it by 36. Okay. 95 divided by 19. That tells us how many times 19 goes into 95. And then we're going to multiply that by 36. And we get 180. Therefore, the whole team scored 180 runs. Now, just to make sure that you're on the right track, okay, the ratio 180 to 95, so I'll just do this as a double check, okay. Okay, should equal the ratio 36 to 19. The way we can check that quickly is we enter it in as a fraction. 180 over 95, because fractions and ratios are related. You get 36 to 19. And it works. Question 19. The heights in centimeters of 10 players on a basketball team are as shown. Is the height of the shortest player on the team considered an outlier? Justify your answer with calculations. First thing to note, if you look at the scores, they're listed in ascending order. Second thing is we're dealing with outliers, which means that we want to determine whether 170, the shortest player on the team, is considered an outlier or not. So we need to calculate where the boundary for an outlier would lie, and that is related to the quartiles. Now the Q3 and Q1. So it's actually going to be related to Q1, the lower quartile. And we need to work out how far below the lower quartile we need to go before a score then is considered an outlier. So let's work out where the quartiles are first. Okay, so there's 10 scores. 1, 2, 3, 4, 5. So the median, which we need to work out first, is between the 5th and 6th scores. So between 192 and 193. So the median is there. Okay, and this is 192.5. Let's have a look at the bottom 5 scores. The median of the bottom 5 scores is 185. So that's our Q1. The median of the upper 5 scores is Q3, which is 194. Now we need to work out the interquartile range, because now we're sort of on our way to calculating this boundary value. Okay, so outside of which a score is then considered an outlier. Okay, so first of all, interquartile range is equal to Q3 minus Q1 Okay. Interquartile range is equal to 194 minus 185, and that's equal to 9. Next thing we need to calculate is the lower boundary for an outlier. Okay. Is equal to, it's actually equal to Q1 minus 1.5 multiplied by the interquartile range. Okay, so Q1 is 185 minus 1.5 multiplied by the interquartile range, which is 9. So let's calculate what that lower boundary is. Okay, so 185 minus 1.5 multiplied by 9, and we get 171.5 centimeters. Now, the shortest player is 170 centimeters. Which is less than 171.5 centimeters. Therefore, is considered 170 centimeters is considered an outlier. Question 20. A roulette wheel has the numbers 0, 1, 2, right up to 36, where each of the 37 numbers is equally likely to be spun. If the wheel is spun 18,500 times, calculate the expected frequency of spinning the number 8. So there's 37 numbers, each equally likely. So the probability of spinning an 8 is 1 on 37. Now the number of 8s that we're expected to get, assuming sort of a perfect world, every 37 spins, or in 37 spins, an 8 should turn up once. That's the expected number. So in 18,500 spins, the expected frequency is given by 1 on 37, which is the probability of getting an 8 in one spin, multiplied by the number of spins. 1 on 37 multiplied by 18,500. Which is 500. Question 21. A person owns 1,526 shares with a market value of $8.75 per share. The total dividend received for these shares is $1,068.20. Calculate the percentage dividend yield. So usually that's a dividend yield per share. And we need to work out what is the dividend per share first, and then we're going to divide it by the share price and then multiply it by 100 to convert it into a percentage. So dividend per share is equal to the total dividend, which is $1,068.20, and we divide it by the number of shares, which is 1,526. Okay, so 1068.20 divided by 1526, and we get 70 cents a share. So that's the dividend received per share. Now, the percentage dividend yield is equal to the dividend per share, which is 70 cents, which you just worked out. We divide it by the market value of one share, which is $8.75. And then we're going to multiply it by 100 because we want it as a percentage, because that's what the question asks for. Okay, so 0.7 divided by $8.75, multiply that by 100, and we get 8%. Question 22. Two right-angled triangles, ABC and ADC, are shown. Calculate the size of angle theta, correct to the nearest minute. Now let's analyze this diagram for a moment. We have triangle ADC, that's a right-angled triangle. We have a triangle ABC, that's also a right-angled triangle. In fact, AC is a common hypotenuse. Now, when you think of right-angled triangles, two things should automatically come to mind: Pythagoras theorem and trigonometry. Now we want to find angle theta, that's really the prize here. But in order to find angle theta, I need two sides of this triangle ABC, two known sides. I've only got one known side. So I need side AC. BC, at the moment I've got no chance of finding that. But AC, we can, and we can use triangle ADC, this triangle here, and Pythagoras theorem, of course, to calculate the length of AC. So let's do that. So by Pythagoras theorem, AC squared is equal to 2.5 squared plus 6 squared. 2.5 squared plus 6 squared, and we get 42.25. Therefore, AC is equal to the square root of 42.25, and let's express that in decimal. We could either leave it in surd form, or we can express it in decimal. In fact, it's only 6.5. It's not a decimal that sort of goes on forever. Okay, so that's equal to 6.5 centimeters. In fact, so that's this one here. We could add that onto the diagram. Okay, now if you turn the page around, right, you can see the right angle triangle there, right? And we have our angle theta. This would be our adjacent side. This would be our hypotenuse. Now, according to Sokotoa, okay, if you want to use SOHCAHTOA, okay, that's your basic right angle trigonometry. This is going to be cos, isn't it? Okay, so cos of theta is equal to adjacent over the hypotenuse. So that's 4.9 over 6.5. Make theta the subject of the formula. So we move the cos over, and it becomes inverse cos. So cos with a -1, a shift cos on your calculator. 4.9 over 6.5. Okay. So shift cos. Okay. 4.9 over 6.5. We get 41.0753, but we want it to the nearest minute. Okay, so we'll press this button here, degrees, minutes, seconds. We get 41 degrees. Okay, you can see that. Yep, 4 minutes, 31.26 seconds. Now we need it rounded to the nearest minute, correct to the nearest minute. So that's going to be 41 degrees. The 4 minutes is going to become 5 minutes because it's 30 seconds and above, rounds the minute up by 1. Question 23. A set of bivariate data is collected by measuring the height and arm span of 7 children. The graph shows a scatter plot of these measurements. Part A. Calculate Pearson's correlation coefficient for the data, correct to 2 decimal places. Part B. Identify the direction and strength of the linear association between height and arm span. In Part C, the equation of the least squares regression line is shown. A child has an arm span of 143 centimeters. Calculate the predicted height for this child using the equation of the least squares regression line. So let's have a look at part A, which is to calculate Pearson's correlation coefficient for the data. So we're going to turn the calculator on, put it into stat mode, so we'll press mode number 2, stat, and because it's bivariate data, we're going to go to mode 2, okay, and you'll see the two columns X and Y, so let's enter in the data. Okay, so this first point here is 136 for X. Actually, it might be quicker if you just do all the X values first, and then we'll do all the Y values. Because every time you press equals, the cursor goes down on the calculator, it doesn't go across. So this one here is 140. Okay, this one is, there's 244s. 144. We have 146. And we have 148. Okay. Now let's scroll back up and let's do the Y values. So we have 142. We have another one that's 142. This one's 146. This one's 148. This one's 149. This one's 150. And this one is 152. Press AC. Okay. Now, bring up the statistics menu, Shift 1, and number 5, Reg. And option 3, R. We get 0.98. Now it says identify the direction and strength of the linear association. Now the correlation coefficient is positive and it's very close to 1. So this would be a positive and strong. Linear association. And you can see that actually from the dots on the scatter plot, that if you were to draw a line of best fit, the dots they align fairly close to the line. So you'd expect it to be, it's positive, and you'd expect it to be a strong, wouldn't say probably moderate, but anyways. Part C, the equation of the least squares regression line is shown. So a child has an arm span of 143 centimeters. Calculate the predicted height. So this is just substitution. So height is equal to 0.866 multiplied by arm span, and arm span 143 plus 23.7. 0.866 multiplied by 143 plus 23.7, and we get 147.538. And we can round that to the nearest centimeter. So this will be 148 centimeters to the nearest centimeter. Question 24. Amanda uses 80 kilocalories of energy per kilometre while she is running. She eats a burger that contains 2,180 kilojoules of energy. How many kilometres will she need to run to use up all the energy from the burger? Give your answer correct to one decimal place. 1 kilocalorie is equal to 4.184 kilojoules. So what we're going to do is we're going to convert the 80 kilocalories of energy per kilometre while she was running. We're going to convert the 80 kilocalories into kilojoules. So 80 kilocalories, we're going to multiply that by 4.184. Okay, 80 times 4.184, and we get 334.72. Kilojoules. Okay. Now the burger contains 2,180 kilojoules. We're going to divide that by 334.72. to work out how many kilometers Amanda would need to run. And we get 6.5129. And that's in kilometers, but we need to enter to one decimal place. So that's equal to 6.5 kilometers. Question 25. A bowl of fruit contains 17 apples, of which 9 are red and 8 are green. Dennis takes one apple at random and eats it. Margaret also takes an apple at random and eats it. By drawing a probability tree diagram or otherwise, find the probability that Dennis and Margaret eat apples of the same color. Now, in situations like this, it doesn't matter whether it's two people choosing an apple each or one person choosing 2 apples. And the question is basically still the same. What is the probability of choosing 2 apples of the same color? And we're going to represent this with a tree diagram. So I'm just going to start it here. Our first choice, we can choose a red or a green. And our second choice, we can again choose red and green, and red and green, independent of what our first choice was. We can still choose a red or a green. However, the probabilities will differ. This is probability without replacement. So these are dependent events, in other words. In other words, your second choice depends on the probability of the second choice depends on what you got in the first choice. Now, originally we have 17 apples in the bowl. So the probabilities are going to be over 17. There are 9 red and there are 8 green. So the probability will be 9 on 17 for red, 8 on 17 for green. Now for the second choice, we've now depleted the bowl by 1 apple. So these are going to be probabilities over 16. So we've chosen 1 red apple already, which means we now have 1 less red apple. So that'll be 8 on 16 for the second red apple, or to choose the second red apple. Green apples though are still the same in terms of the number of apples. We have 8 green apples. 8 plus 8 gives us 16. There's 16 apples in the bowl. Now if we've chosen a green apple, the red apples are still the same number as originally, which is 9. However, we've already chosen a green apple, so instead of having 8 apples, we now have 7. So the two probabilities that we're looking for, the two favorable events that we're looking for, are the red reds or the green green. So they're the 2 apples that are the same color. So probability of red red is equal to 9 on 17 multiplied by 8 on 16. Probability of green green is equal to 8 on 17 multiplied by 7 on 16. What we do then is we add those two together. So the probability of red red or green green is equal to 9 on 17 multiplied by 8 on 16 plus 8 on 17 multiplied by 7 on 16. And let's do that now. Okay, so 9 on 17 multiplied by 8 on 16 plus 8 on 17 multiplied by 7 on 16. And we get 8 on 17 as the probability. Question 26. A project requires activities A to F to be completed. The activity chart shows the immediate prerequisites and duration for each activity. So part A, by drawing a network diagram, determine the minimum time for the project to be completed. And part B, determine the float time of the non-critical activity. So let's have a look at the table. So we have activity A, does not have any prerequisites. So we can draw a vertex here, and that's our start. Our start vertex, and we'll draw one edge representing activity A, and its duration is 2 hours. Now, activities B and C both depend on activity A being completed. So those two can branch off, one there and one there. So activity B takes 6 hours, and activity C takes 5 hours. Now, as we do those, I'd like to sometimes tick these off to say, yep, I've now got them accounted for in the diagram. Okay, activity D depends on activity B. Okay, so now what I'm going to do though is, rather than drawing it across, notice that activity E depends on C and D, but D depends on B. So what I could do is draw activity D as an edge joining B and C with a down arrow like that. So there's activity D, and D takes 2 hours. Now, activity E depends on C and D. So C and D meet up at this vertex here, which means I could draw an edge this way, and this is activity E, and that takes 4 hours. And finally, activity F depends on activity E, and that takes us to the end. And there's our end vertex. Okay, your diagram might look a little bit different. That's fine, as long as the connections and the sequence of activities match the table, then that's not an issue at all. Okay, all right. So we didn't have to use any dummy activities or anything. Let's now do the critical path analysis. So I might draw some dominoes here. And there's one here as well, one here, one here, and one here. Okay. So from the start, A must be on the critical path. It's the only activity from the start. So there's 2 hours there. Now, from activity A, we have activity B. That takes 6 hours. Add it onto 2. And this will be 8. So this is we're doing the forward scanning now. So this is to find the earliest start times of all the activities. Now, what do we put in this box here? 2 plus 5 is 7. 8 plus 2 is 10. We put the higher number. Okay, there's 2 ways to get to this vertex. And whichever way takes the longest, that's what you need to write down. Because we can't start activity E unless all these activities are completed first. Now, the rest of these activities are all on the critical path because it's the only path. So 10 plus 4 is 14. 14 plus 1 is 15. So the minimum time is 15 hours. Now let's do the backward scanning. So starting from 15, 15 minus 1 is 14. 14 minus 4 is 10, and that makes sense. Now we've got 10 minus 2 is 8. Now there's 2 ways now to get to this vertex here. We can do 10 minus 5, which gives you 5, or we can do 8 minus 6, which gives you 2. You put the higher number now. So 10 minus 5 is 5. Now, let's determine the float time of the non-critical activity, because this is what we've just done there, is to determine part B. So the non-critical activity, okay, is the activity that comes after this domino here. So the float time of the non-critical activity is activity C. So the EST, earliest start time for C, is 2. The latest start time for C is 5. Therefore, the float for C is equal to 5 minus 2, which equals 3 hours. Question 27. Ashley has a credit card with the following conditions. There is no interest-free period. Interest is charged at the end of each month at 18.25% per annum, compounding daily from the purchase date, which is included, to the last day of the month, which is also included. Ashley's credit card statement for April is shown with some figures missing. So there's the statement there. The minimum payment is calculated as 2% of the closing balance on the 30th of April. Calculate the minimum payment. Let's just go back to the question again. Okay, there's no interest-free period, which is good. And interest is charged at the end of each month, 18.25% per annum, compounded daily. So we need the daily interest rate. Okay, so I might just write that here first of all. So the daily interest rate is equal to 18.25%, but it's per day, not per year. It's not per annum. We divide it by 365 because 365 days in a year. The other thing we need to know is the number of days from the date of purchase, 20th of April, to the closing balance, which is on the 30th of April, but we have to include the purchase date and the date of payment. So the number of days is equal to 30th of April minus the 20th of April, and we have to add on a day. And that gives us 11 days. Now we need to apply the compound interest formula to work out the closing balance. So that's the future value formula. Okay, so the future value or closing balance is equal to PV, present value, which is $3,700, multiplied by 1 plus the interest rate. So that's going to be 18.25% over 365 to the power of 11, because interest is compounded daily. So let's work that out now to the nearest cent. So 3,700 multiplied by 1 plus, okay, and it's going to be 18.25%. Make sure you use the percentage symbol there. Okay, might just brighten that a little bit. Yep. Over 365, close bracket, to the power of 11, and we get $3,720.40. Okay, but that's not the minimum payment. The minimum payment is calculated as 2% of the closing balance. Okay, so is equal to 2% of 3,720.40. Okay. Multiplied by 2%, and we get $74.41. Okay. and that's the minimum payment. Question 28. The formula below is used to calculate an estimate for blood alcohol content, BAC, for females. The number of hours required for a person to reach 0 BAC after they stop consuming alcohol is given by the following formula. The number of standard drinks in a glass of wine and a glass of spirits is shown. Hannah weighs 60 kilograms. She consumed 3 glasses of wine and 4 glasses of spirits between 6:15 p.m. and 12:30 a.m. the following day. She then stopped drinking alcohol. Using the given formula, calculate the time in the morning when Hannah's BAC should reach 0. So let's just quickly recap this formula. The BAC formula: N is the number of standard drinks, H is the number of hours drinking, and M is the body mass of the person. So let's work out first of all how many standard drinks were consumed. So she consumed 3 glasses of wine, 3 times 1.2 standard drinks per glass, plus 4 glasses of spirits, and a glass of spirits is 1 standard drink, so we can just add 4 to that. Okay, so 3 times 1.2 plus 4 is 7.6. Now let's work out the number of hours drinking. Okay, we've got 12:30 a.m. okay, is the end, 6:15 p.m. is the beginning. So you could do it in various ways. So you could work out 6:15 p.m. to 11:15 p.m. Yeah, and that's equal to 5 hours. And then from 11:15 p.m. to 12:30 a.m. is 1 hour and 15 minutes. Okay. If you add those two together, so total time is equal to 5 hours plus 1 hour and 15 minutes, and that equals 6 hours and 15 minutes. Now this needs to be converted into decimal. Okay, and we can use the DMS button here. Okay, 6 hours, 15 minutes. So if you don't know it offhand, so that's going to be 6 1/4 hours. Okay, but you could use this button here. So if you have a mental blank, 6.25 hours. Okay, so that gives us our H in the formula. Now let's apply the BAC formula. Okay, and that's equal to 10 times N, which is the number of drinks, which was 7.6. Okay, minus 7.5 H, which is the number of hours drinking, all over 5.5 multiplied by Hannah's mass, which is 60 kilograms. So 10 times 7.6 minus 7.5 times 6.25 over 5.5 multiplied by 60. And we'll press the SD button there, so that's equal to, right, you can see that there. Right, I'm going to write a few decimal places, 0, 8, 8, 2, 5, 7, 5, dot, dot, dot. Okay, as long as you show 6 or 7 decimal places, the the rounding will be fine, okay, at the end, and you'll get the right answer. Okay, now to get the final mark, the time, or the final 2 marks really, the time to achieve a BAC of 0. So the hours time needed for 0 BAC, okay, is equal to, and we're going to use this formula here, so BAC 0.088255 over 0.015. Okay, 0.0882575 over 0.015. Okay, and if you want, we can press the DMS button, and that gives us 5 hours and 53 minutes. Okay, probably write it a little bit smaller because we're not meant to write in the area there. Yep, 5 hours and 53 minutes. And now to work out what time her blood alcohol will reach 0, 5 hours and 53 minutes, we add that on to the time she stopped drinking, which is 12:30 a.m. Okay, so 5 hours, okay, 53 minutes plus 12:30 a.m. Okay, you could also use the DMS button here for adding on time or adding time. 5 hours, 53 minutes plus 12:30 a.m. Now in 24-hour time, and we should be using 24-hour time, that's 0 hours, 30 minutes. And we get 6:23 a.m. So a bit clearer there. a.m. And that's the time, or the approximate time, when her blood alcohol content will be 0. Question 29. Part of a supermarket receipt is shown. Okay, so just going through this quickly, we have some items. Notice that one of these items has an asterisk there. If you go down to the bottom of the receipt, it says that asterisk refers to GST. That GST applies to this item. The question is to determine the missing values A and B to complete the receipt. And we can see that these 2 items there are missing. So let's have a look at the chocolates first. The chocolates has an asterisk next to it. That means that there's GST that applies. Notice that there's no other items that have GST that's applicable to them. Now we know that 70 cents is the GST that applies to the chocolates. Now to get the selling price then of the chocolates, rather than dividing by 11 to find the GST, if you have the GST, if you multiply it by 11, you then get the selling price of the chocolates. So item A, okay, is equal to the GST amount. Multiply that by 11, okay, and we get $7.70. And we can just add this onto the receipt here, $7.70. Now, to find the price of the almonds, we know the total price of, well, that's on the total price of all the items that's on the receipt. If you subtract all the known values from $36.25, we then get item B, which is the price of the almonds. So B is equal to $36.25 minus $7.70 minus $5 minus $8.50 minus $3.20 minus $2.85. So it's a fairly basic calculation, but just quite a few numbers there that you have to enter in. Minus $7.70 minus 5 minus $8.50 minus $3.20 minus $2.85. and we get $9. So the price of the almonds is $9. Question 30. The network diagram shows the tracks connecting 8 picnic sites in a nature park. The vertices A to H represent the picnic sites. The weights on the edges represent the distances along the tracks between the picnic sites in kilometres. Part A. Each picnic site needs to provide drinking water. The main water source is at site A. By drawing a minimum spanning tree in the space below, calculate the minimum length of water pipes required to supply water to all the sites if the water pipes can only be laid along the tracks. So what we're going to do is just draw in the vertices first. Okay, so there's A. Okay, we got B. Okay, we got C up the top. Okay, G up the bottom. Okay, we've got F here. Okay, we've got E here. And we've got D up the top. Okay, there we go. And we've got H somewhere here, just above F. Okay, so what we're going to do is we're going to apply Kruskal's algorithm. Kruskal's algorithm is probably a little bit easier than Prim's. It's just a matter of just selecting the lowest weight edges first and in ascending order. So we can select edge GF. Okay, so it connects those two. Okay, now let's have a look. There's no more edges of weight 1. Let's have a look at the edges of weight 2. We've got 1 there between G and H. Okay. Yep. Okay, so that the no other edges of weight 2. Weight 3, we have 1 edge here. Okay, which is CH. Okay, so that's that one done. Okay, now weight 4s. Okay, we got AB. And we've also got CG. Okay, just here, CG. But we can't use that edge because that then creates a cycle, okay, a closed path. So we can't use this edge here. So that's all the weight 4s. What about the edges of weight 5? Okay, so we've got BC. Okay. Okay, and we've also got DH and EH as well. Okay, so what I'll do is I'm just going to draw in the weights as well. That's a 2, that's a 1, that's a 5, that's a 3, and that's a 4. Now, to get the minimum length, we just add the numbers. Okay, so we have 1 plus 2 plus 3 plus 4, and we've got 5 plus 5 plus 5, which is 15. And so the answer is 25. Now, part B. One day, the track between C and H is closed. State the vertices that identify the shortest path from C to E that avoids the closed track. Okay, so CH is now closed. Okay, so that's gone. Okay, but we need to get from C to E. So we can either go CG, CGHE. We can go CGFE. So there's a weight 7 there. We could go CDE. So that's 7 plus 5 is 12. So we try and identify whichever part's the lowest weight. So we have a 12, CDE is 12, so I might just write these down. Okay, so there's 12. We have CGFE. Okay, C, G, F, E. So 4 plus 1 plus 7 is also 12. Could we get one that's less than 12? C, G, H, E. So 4 plus 2 plus 5 is 11. So far, C, G, H, E is the path of lowest weight, or the shortest path. So I can't see any others there. So just try and identify all the different paths. So going this way, there's no chance going backwards. You end up with the weight of the path being greater than 12. So C, G, H, E would be the answer there. So C, G, H, E, and that's equal to 11. Question 31. A rectangle has width W centimeters. The area of the rectangle A in square centimeters is A equals 2W squared plus 5W. The graph of A equals 2W squared plus 5W is shown. Okay. So part A. Explain why in this context the model A equals 2W squared plus 5W only makes sense for the bold section of the graph. And I think if you look on the x-axis here, the W here represents the width of a rectangle. The width makes no sense if the width is a negative number, like -1 centimeters. Okay, so Okay, so anything to that effect, there's 1 mark. Now the area of the rectangle is 18 square centimeters. Calculate the perimeter of this rectangle. So if we're talking about perimeter, and I might just sketch a rectangle here. Okay, there's width and there's the length. So we want the distance around the rectangle. So let's first of all work out the width from the area. Okay, so we're told that the area of this rectangle is 18 square centimeters. So let's use the graph then to work out what the width should be. So using a ruler, okay, so there's 15 square centimeters, 16, 17, 18. Okay, so the y-axis represents the area of the rectangle. Okay, you draw a line across, find out where it intersects with the graph. Okay, if you project downwards, okay, you can see there that the width must be 2. Okay, so using the graph, okay, and I guess just to show you working out, just to make sure that you've shown you working out, okay, you can see that you've used the graph there to project across and then project down. Using the graph, okay, a width of 2 centimeters gives an area of 18 square centimeters. Okay. So that means then that the width is 2. Okay. Now we need to work out the length. Okay. So area is equal to width times length. The area of the rectangle is 18 square centimeters. So 18 is equal to, now the width is 2 multiplied by length. Therefore, length is 9 centimeters. So what's the perimeter? Hence the perimeter is equal to 2 times 9, because you have a 9 up here and you have a 2 here. Right? 2 times 9 plus 2 times 2. Okay, so that's 18 plus 4. Therefore, perimeter equals 22 centimeters. Question 32. The table shows the income tax rates for the 2018-2019 financial year. The Medicare levy is calculated as 2% of the taxable income. For the 2018-2019 financial year, Charlie pays a Medicare levy of $1,934.80. Calculate the tax payable on Charlie's taxable income. Now, the first thing we need to do is to work out what 100% of the taxable income is, given that 2% of the taxable income correlates to $1,984.80. So, if 2% correlates to $1,934.80, if we divide this by 2, this is the unitary method, multiply that by 100. We do the same thing here, divide that by 2, multiply that by 100. To get 100%, we get taxable income is equal to 1934.80, divide that by 2%, multiply that by 100 to get 100% of the taxable income there, $96,740. So that's Charlie's taxable income. Now we need to use this taxable income to calculate his tax payable. So 96,000, this will be this row here. Okay, so I just put an arrow there just to say this is the row that I'm referring to. So let's follow the rule. Okay, the tax owed is equal to $20,797 plus 37 cents for each dollar over 90,000. That's easy enough to do. 37 cents for each dollar just means 37%. Multiplied by, now, how much over 90,000 are we, and how are we going to calculate that? With a subtraction. $96,740 minus 90,000. Okay, you could easily see that it's going to be $6,740. Enter that into your calculator. Okay, so 2797 plus 37% multiplied by 96,740 minus $90,000. Press the SD button, and that's going to be $23,290.80 in tax. Question 33. The time taken for a car to travel between two towns at a constant speed varies inversely with its speed. It takes 1.5 hours for the car to travel between the two towns at a constant speed of 80 kilometers an hour. So I'm just going to underline the word inversely there. Calculate the distance between the two towns. Now, distance is equal to speed multiplied by time. Now, we can draw one of these to help us. So this is the distance, speed, time triangle. Okay, so distance is equal to speed multiplied by time. Time is equal to distance over speed. Okay, speed is equal to distance over time. So distance is equal to the speed, 80 kilometers an hour, multiplied by time, and the time is 1.5 hours. Multiplying those two numbers together, okay, 80 multiplied by 1.5, and that's 120 kilometers. So the two towns are 120 kilometers apart from each other. Part B. By first plotting 4 points, draw the curve that shows the time taken to travel between the two towns at different constant speeds. Now, we know that the relationship is an inverse one. In other words, if we double the speed, we halve the time taken, and that makes sense, doesn't it? We know at 80 kilometers an hour, okay, it takes 1.5 hours to get from one town to the other. If we halve the speed, so instead of traveling at 80 kilometers an hour, we travel at 40 kilometers an hour. Okay, it's going to take double the time. That makes sense. You slow down, it's going to take longer. It's going to be double 1.5, so that'll be 3 hours. Now, if we halve the speed again, in other words, half of 40, we're going to travel at 20 kilometers an hour. It's going to take double the time again. So instead of 3 hours, it's going to take 6 hours. Now we need one more point. So if we halve 20, you get 10. We don't have enough. The y-axis isn't long enough to put 12 hours or to plot the point there. So we need a point in between, because the question clearly states we need to plot 4 points. Now if we go back to the distance, speed, time triangle, we need the formula in terms of time. So time is equal to distance over speed. We know the distance, which is 120 kilometers, over, let's pick a point, let's say 60 kilometers an hour. So 120 kilometers over 60 kilometers an hour equals 2 hours. Okay, so we can plot another point here. So that's 60 kilometers an hour, it's going to take 2 hours. We now have 4 points. We can now draw the curve. So might just this is probably best done with pencil. Okay, something like that, and that'll give you your 3 marks. Question 34. The relationship between British pounds P and Australian dollars D on a particular day is shown in the graph. And in particular, have a look at this point here in the graph. So this point here implies that 7 Australian dollars gives us 4 British pounds. Part A. Write the direct variation equation relating British pounds to Australian dollars in the form P equals MD. Leave M as a fraction. So direct variation implies that it starts from the origin at 0, 0. So we only need 1 point or one known point to work out the gradient M, okay, or the constant of variation if it's the letter K. So P equals MD, pounds 4 is equal to M times the amount of Australian dollars to give you 4 British pounds, which is 7. Making M the subject of the formula, so rearranging the equation, we have M is equal to 4 divided by 7. 4 over 7. Therefore, the equation is P is equal to 4 over 7 D. Okay. Part B. The relationship between Japanese yen and Australian dollars on the same day is given by the equation y equals 76D. Now, y is yen, D is Australian dollars, so very similar to the last question. Convert 93,100 Japanese yen to British pounds. So there's 2 steps involved here. First of all, let's convert the Japanese yen to the Australian dollar, because from there we can use part A to convert Australian dollars to British pounds. So let's work this up. So y equals 76D. Okay. Now we have 93,100 Japanese yen. So 93,100 is equal to 76 multiplied by Australian dollars, dividing both sides by 76. So D is equal to 93,100 divided by 76. D equals, okay, so 93,100 divided by 76, and we get 1,225 Australian dollars. Now we need to use part A to convert 1,225 Australian dollars into British pounds. So from part A, okay, P is equal to 4 on 7 times D, which is 1,225. Okay, multiplying that together. Okay, so 4 on 7 multiplied by 1,225, and that gives us 700. Question 35. A compass radial survey shows the positions of 4 towns, A, B, C, and D, relative to point O. The area of triangle BOC is 198 square kilometres. Calculate the bearing of town C from point O, correct to the nearest degree. So let's have a look at the radial survey. As we go from one town to another, whatever the angle is inside the triangle is added to the bearing to give us the bearing of the next town clockwise. So in order to get the bearing of town C, we need the bearing of town B plus this unknown angle here. So now let's focus on triangle BOC. We need this angle here, we know the area, and we know 2 sides. And the angle that we want is the included angle between the 2 known sides. So we need to use the sine rule for area of the triangle. So, in triangle BOC, 198 square kilometres is equal to half AB sine C. So half multiplied by 25 multiplied by 16 multiplied by sine of C. So let's solve now for C. So half multiplied by 25 multiplied by 16 is equal to 200. Okay. Now we need to make sine C the subject of the formula. Okay. So sine C is being multiplied by 200. When we move the 200 over, 198 divided by 200 is equal to sine of C. But we need angle C to be the subject. So we take the inverse sine or shift sign on the calculator of the left hand side, divide that by 200 is equal to C. And we get 81.89 degrees. So we'll work to 2 decimal places, but eventually we're going to round it to the nearest degree. Okay, so this one's going to be 81.89 degrees. We're just going to add it to the bearing of town B, and we'll get the bearing of town C. So okay, is equal to 125 degrees plus 81.89 degrees. We always round at the end. Okay, so plus that, add that to 125, we get 206.89. 9 degrees, and rounding that to the nearest degree, that's going to be 207 degrees. Question 36. A small business makes and sells birdhouses. Technology was used to draw straight line graphs to represent the cost of making birdhouses, C, and the revenue from selling birdhouses, R. The x-axis displays the number of birdhouses and the y-axis displays the cost or revenue in dollars. So there's the graph. Part A, how many birdhouses need to be sold to break even? So this is where the revenue equals the cost. So just find where they intersect, project down to the x-axis, and we can see here that 20 birdhouses need to be sold in order to break even. Break even means you're not making a loss or a profit. So the answer is 20. Now part B, by first forming equations for cost and revenue, determine how many birdhouses need to be sold to earn a profit of $1,900. So profit is the difference between revenue and cost, and it's going to be 1,900. So we need to form these 2 equations and then form another equation where R minus C is equal to 1,900. So let's do this first. So let's work out the revenue first, or the equation for revenue. Okay, so that's the solid line. Okay, the y-intercept is 0, so this is an example of direct variation. Okay, so it's just going to be in the form y equals mx. Okay, so the gradient, okay, is equal to rise over run. Okay, so we can just choose a convenient right angle triangle. So we might just choose this one here. The run is 10 and the rise is 400. So if you go up on the y-axis, it goes up in steps of $100. Okay, so that's going to be 400. So the gradient is 40. Okay, y-intercept is 0. Therefore, revenue is equal to 40x. Now let's have a look at the equation that represents the cost. And we're going to do the same thing again. Let's work out the gradient first. Okay. So the cost is the dotted line. Let's find a convenient right angle triangle. We might use this one here. Okay, so you can see where I'm pointing here. So the run is 20. Okay, run is 20. And the rise, 1, 2, 3. Okay, that's $300. Okay. 300 divided by 20 should give us 15. Okay, and the y-intercept is here, 500. Therefore, cost C is equal to 15x, our gradient times x, plus 500. Now what we're going to do is form another equation and solve for x for the profit. Okay, so profit. Okay, R minus C is equal to $1,900. Okay, so the revenue is 40x minus the cost, which is 15x plus 500 is equal to 1,900. Let's now expand the brackets. 40x minus 15x minus 500 is equal to 1,900. Let's now combine the like terms. 40x minus 15x is 25x. And 1,900 plus 500, so this 500 is going to move over. Right? And we're going to get 1,900 plus 500 should be 2,400. X is equal to 2,400. We're going to divide that by 25. So this 25 is going to be used to divide the 2,400 by 25. So, okay. 2,400 divided by 25, and we get 96. Therefore, need to sell 96. Just be careful anytime you write anything that you must stay above this line and you must stay inside this dotted line here. Question 37. A new car is bought for $24,950. Each year, the value of the car is depreciated by the same percentage. The table shows the value of the car based on the declining balance method of depreciation for the first 3 years. What is the value of the car at the end of 10 years? Now, declining balance means that it's losing a set percentage or a constant percentage based on the previous year or relative to the previous year. So if we're starting off at 24,950, at the end of the first year, the car is now worth 21,457. So let's work out what the depreciation is first, then we'll work out the percentage, and then we can go from there. Right, so the depreciation in the first year is equal to the original value, so 24,000, so the purchase price in other words, minus the value of the car after year number 1. Okay, so 24,950 minus 21,457, and we get $3,493 in the first year. Now in each year it's going to lose a different amount because it's declining balance method. Okay, declining balance method looks like this. Okay, so it loses a lot in the first year or two, and then the loss is less and less as the time gets away. Right, so the percentage, okay, is equal to the depreciation, okay, at the end of the first year over the original value, okay, which is 24,950. Then we multiply that by 100. Okay, so 3493 over 24,950. We multiply that by 100, and we get 14%. Okay, so the depreciation each year is 14% compared to the year before. Okay, so the value of the car after 10 years, okay, value is equal to the original price multiplied by 1 minus 14% to the power of 10. Okay. Shift percent. So notice, okay, it's very important that you actually type it in the calculator as it's written, to the power of 10, and we get 5521.47. And that's the value of the car after 10 years. Question 38. In a particular country, the birth weight of babies is normally distributed with a mean of 3,000 grams. It is known that 95% of these babies have a birth weight between 1,600 grams and 4,400 grams. One of these babies has a birth weight of 3,497 grams. What is the Z-score of this baby's birth weight? So the first thing to note is we have 95% of these babies have a birth weight between 1,600 grams, 4,400 grams. 95% of scores on a normal distribution lie between Z equals -2 and Z equals +2. So that's -2 standard deviations to +2 standard deviations. So 4 standard deviations is equal to 4,400 minus 1,600. Okay. So 4,400 minus 1,600, and we have 2,800. Okay. Therefore, one standard deviation is equal to 2,800 divided by 4, which equals 700. Now that we've found the standard deviation, we can then proceed to find the Z-score of this particular baby. So Z-score for 3,497, and we're going to use the formula for Z-score, which is the raw score, 3,497, minus the mean, which is 3,000 grams, over 700. 3,497 minus 3,000 over the standard deviation that we just found, which is 700. And we get 0.71, positive 0.71. Question 39. Two netball teams, Team A and Team B, each played 15 games in a tournament. For each team, the number of goals scored in each game was recorded. The frequency table shows the data for Team A. The data for Team B was analysed to create the box plot shown. Compare the distributions of the number of goals scored by the two teams. Support your answer with the construction of a box plot for the data for Team A. So the first thing we're going to do is generate our 5-number summary. Now, straight away, the minimum score for Team A, I might just write it here on the side. So min score is equal to 19. We need the first quartile, we need the median, we need the third quartile, and we need the max score. And we know what the max score is, it's 28. We're going to use these 5 numbers to draw our box plot for Team A. So first thing we're going to do is put our calculator into stat mode. So mode 2 and then 1 var. Now notice that we need a frequency column. So shift, mode setup, okay, scroll down, STAT number 3 and then frequency on. Right, now let's enter in the data. So what I'm going to do is I'm going to enter in one column at a time. So 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So they're the scores. Let's enter in now the frequencies associated with those scores. So 19 is 1, 20 is 0, 21 is 1, 22 is 1, 23 is 1, 24 is 3, so let's enter in 3, 25 is 0, 26 is 4, 27 is 3, 28 is 1. So one thing I do just very quickly is just check to make sure that they're entered in okay or accurately. 19, 20, 0, 21, 1, 22, 1, 23, 1, 24, 3, 25, 0, 26 should be 4, 27 should be 3, 28 should be 1, so that looks okay. All right, so we know what our min and max are. Let's generate quartile 1 and median and quartile 3. Shift 1, min max, number 5, number 3, Q1 equals 23. Now, median, shift 1, min max, number 5, median, number 4 there, 26. Now the third quartile, min max, number 5, quartile 3, number 5 there, and we've got 27. We now have the data that we need to draw our box plot. So minimum score is 19, so I might just put a little dot there. Okay, quartile 1 is 23, median is 26, okay, quartile 3 is 27, and the maximum score is 28. So, okay, now let's draw it in. So, okay, so we'll draw in the tails. Okay, now we'll draw in the box. Okay, please use a ruler to do this. And our median line. Okay, so a grid's provided, does make it a lot easier to draw in. So there you go. There's our completed box plot for Team A. Let's analyse this quickly. First of all, we can see that the interquartile range, okay, hopefully you can see that, interquartile range for Team A is less than Team B, which means Team A is more consistent. Okay. Next thing to note is that the positioning of the two boxes, including their medians, Team A's box, okay, with their median is lower than the box for Team B. Okay, so that's which implies Team A performed, or we can say that Team A did not perform as well as Team B. Okay, something else to note as well is look at the whisker for Team A. It's clearly much longer than the whisker for Team B. So, and also the positioning of the median as well. So this implies that Team A's, the distribution for the scores of Team A is negatively skewed. Okay, so all right, so the lower tail is much longer than the upper tail for Team A, which implies a negatively skewed distribution. So that means potentially it could be a few players that might not be doing so well. Okay, whereby Team B shows a symmetrical distribution according to their box and whisker plot to the similar length whiskers. And the centrally located median. I've gone slightly over there, but I think that's fairly comprehensive. Question 40. A museum is planning an exhibition using 5 rooms. The museum manager draws a network to help plan the exhibition. The vertices A, B, C, D, and E represent the 5 rooms. The numbers on the edges represent the maximum number of people per hour who can pass through the security checkpoints between the rooms. What is the capacity of the cut shown? Okay, so here's the cut. Now, the cut is meant to isolate the source from the sink. Okay, we have a 70 here. So that's 70 plus this 90 here is included as well. Okay, so these two edges cut off the flow from vertices C and D. So they're gone. It also cuts off the outflow of C as well. So this 40 does not get included. Since we've cut off everything coming into C anyway, this 40 is not counted. But we have to count the 130, because if we don't cut the 130 off, there's a flow from entry to exit via A, B, E. So we have to add the 130 as well. So adding those together, 70 plus 90 plus 130, we get 290. Okay. Part B. The museum manager is planning for a maximum of 240 visitors to pass through the exhibition each hour. By using the minimum cut maximum flow theorem, the manager determines that the plan does not provide sufficient flow capacity. Draw the minimum cut onto the network below and recommend a change that the manager could make to one or more security checkpoints to increase the flow capacity to 240 visitors per hour. First of all, let's just draw the obvious cuts. Okay, so there's one there. Okay, so that's going to be 80 plus 90 plus 70, which happens to be 240, which is quite interesting. Okay, so which actually equals the inflow to A. We also have this cut here. Okay, and if we add up those edges leading into vertex E, 130 plus 65 plus 45 is also equal to 240. So interestingly enough, vertex A and vertex E are balanced. Okay, so in other words, inflow and outflow are equal, which means that they're maximized. Okay, so let's have a look at a potential cut that we can make. Now we have this cut here. This cut's 290, so that's clearly too big. So let's consider another cut that we could make. I was thinking maybe we can go through here. So maybe this way there. Okay. And we're hoping we can get a number that's in fact less than 240. Maybe. Let's see. So you may have to make this. There's quite a few ways that we can make these cuts. So that's partly the tricky aspect of this type of question, because it's possible to miss a cut. 80 plus 90. Okay, so those two cuts are included. Okay. We also have to cut off the 25 as well, and we also have to cut off the 45. Okay, and we get 240 there. So that's another cut that's equal to the other cuts. So can we come up with another cut that potentially may work? So in other words, a cut that actually gives you a number less than 240. Let's think about maybe one that goes through this way. That way there. Okay, so we have 80. Okay. Plus, now we don't, do we add the 40 there? We do add the 40 there because that's also another inflow into vertex B. Okay. We've got to cut off the 65 because that's an outflow of C, okay, which is an inflow to E. And also 45. And we get 230. Okay. So these four cuts are in fact necessary. Okay, so cutting off the inflow to B cuts off BE. Okay, so these two are important there. And also cutting off these two also cuts off the flow to E via these two edges here. So it looks like 230 may be correct. Now it's only a 2-mark question, so we don't want to waste too much extra time. Okay. Now the recommended change would be to have a look at vertices B, C, and D. Now we know that the inflow to A and the outflow to A is in fact equal. So A is maximized, E is also maximized. Let's have a look at D. The inflow to D is 70, okay, and the outflow of D is also 70. Okay, so vertices A, D, wasn't B actually, it was A, D, and E are maximized. Okay, so if you have a look at vertex C, we got 90 plus 25, okay, is going into C, okay, which is 115, but we've got 105 coming out of C. Okay, I would increase, in fact, this edge here to a capacity of 50. So by changing that to 50, okay, you actually maximize the network. Okay, so we end up with 115 in, 115 out of vertex C. And if you have a look at vertex B, 80 plus 50 going into B gives you 130 coming out of B. So you maximize these two vertices, and that would be the change that would be made. Question 41. A map is drawn to scale on 1 centimetre grid paper, showing the positions of a supermarket and a cinema. A reservoir is also shown. Part A. It takes 10 minutes to walk in a straight line from the cinema to the supermarket at a constant speed of 3 kilometres per hour. Show that the scale of the map is 1 centimetre equals 100 metres. Now, if you notice, we're working in minutes, go for time, and the scale's in metres. So why don't we convert the speed here, this 3 kilometres per hour, into metres per minute? Okay, so let's do that first. So 3 kilometres per hour is equal to 3,000 metres per 60 minutes. So let's work it out now in metres per minute. Okay. So if we divide both of these terms by 60, okay, 3,000 divided by 60, we end up with 50 metres per minute. Okay, so now it takes 10 minutes to walk in a straight line from cinema to supermarket. So in 10 minutes, distance is equal to 50 metres per minute multiplied by 10, which equals 500 metres. So there are 500 metres between cinema and supermarket. 1, 2, 3, 4, 5 grid squares. Equals 500 metres, 1 grid square is equal to 100 metres, 1 grid square is equal to 1 centimetre, therefore the scale is 1 centimetre to 100 metres as required. Okay, so we can add that on here. 1 centimetre is 100 metres. Okay, we're going to need that. So let's have a look at part B. The reservoir is initially empty. During a storm, 20 millimetres of rain falls on the reservoir. With the aid of one application of the trapezoidal rule, estimate the amount of water in the reservoir immediately after the storm. Assume that all rain which falls over the reservoir is stored and give your answer in cubic metres. Let's go back to our reservoir. Okay, so trapezoidal rule, we need the 2 parallel sides of the trapezium. Okay, so what we're doing is we're building a trapezium. Okay, this is 100 metres using our scale. 1, 2, 3. This is 300 metres. Again, using our scale. So that's our scale there. And 1, 2, 3, 4. And the distance between the parallel sides of the trapezium is 400 metres. Okay, so the surface area of the reservoir by the trapezoidal rule is equal to, okay, half multiplied by the distance between the parallel sides. These are the parallel sides basically of the trapezium. If you look at it this way, you can see a trapezium. Okay, so half multiplied by 400 multiplied by the sum of the parallel sides, which is 100 plus 300. Okay, and that's equal to, okay, half multiplied by 400 multiplied by 100 plus 300 is 80,000 square meters. So now during a storm, 20 millimeters of rain falls on the reservoir. Okay, so to estimate the amount of water, the first thing we have to do is convert the 20 millimeters into meters. since the surface area is in meters and we want to answer in cubic meters, that means that the height of water, okay, that's fallen, is the meter equivalent of 20 millimeters. So let's do this. Convert 20 millimeters into meters. Okay, we'll divide that by 1,000. Okay, if you're having a mental blank, just put in your calculator. Right, don't guess your way through this. Make sure you do not lose a mark here. That's 0.02 meters of water that's fallen. So that's going to be the height of water that's fallen. So the volume of water is equal to 80,000 square meters multiplied by the height of water. That's 20 millimeters. Multiplying all that together, and we get 1,600 cubic meters, which is 1,600 kiloliters or 1.6 megaliters. Question 42. The table shows the future values of an annuity of $1 for different interest rates for 4, 5, and 6 years. The contributions are made at the end of each year. And that's very important to note that one. An annuity account is opened and contributions of $2,000 are made at the end of each year for 7 years. For the first 6 years, the interest rate is 4% per annum, compounded annually. For the 7th year, however, the interest rate increases to 5% per annum, compounded annually. So calculate the amount in the account immediately after the 7th contribution is made. Now, just thinking about it, 7 contributions of $2,000, our answer's got to be over $14,000. Okay, so just think about that for a moment. Now, the other thing as well is that for the first 6 years, the interest rate is 4% per annum. So according to our table, we're going to use the last row and the last column, which is this number here. And we're going to multiply that by 2,000 to get the value of our annuity after 6 years, because the 7th year, the interest rate changes to 5% per annum, but it's only 1 year's worth of interest. So we're going to treat that separately and treat it as regular compound interest. Okay. So let's work out the value of the annuity after 6 years. Okay, and that's going to be equal to the contribution, which is $2,000, multiplied by the multiplication or the factor that we're going to multiply by from the table, assuming we chose the correct one, which is going to be 6.633. Okay, and multiplying all that together. Okay, so 2,000 multiplied by 6.633. And we get $13,266. $13,266. Now we need to work out the value of the annuity after the 7th year. But the 7th year, the interest rate changes. So value of annuity after 7 years is equal to whatever we had gotten in the first 6 years, so that's going to be 13,266 multiplied by 1 year's worth of compound interest, because it changes to 5% per annum. So it's just going to be 1 plus 5. And it's 1 year's worth, so it's just to the power of 1, so I'm not going to show that. Okay. So just enter that here. So 13,266 multiplied by 1 plus 5. And we get $13,929.30. Okay. Now, there's one little bit of detail there that we need to make note of. Go back to the question. It says immediately after the 7th contribution is made. That's only after 6 contributions. Okay, so we need to add the last contribution plus $2,000, and that's going to be equal to $15,929.30. Therefore, value of the annuity after the 7th contribution is $15,929.30.